Alright, so this video is about which to choose, shells or dis. So if you look here, we have our functions, and each of these have already been graphed for us to give us the region that we want. So now which do you choose? And so all that means is to draw your shell. So if you're dis, we know that these have to be perpendicular. Perpendicular rectangle. And if you're shells, we know we need to use a parallel rectangle. So if we are rotating this about the x-axis like this, then that means this would be our rectangle for dis, because we have to go perpendicular, and we label it dx and y equals. And this would be our rectangle for shells, and we label it dy and x equals. Well, if you look at the one for shells, it's not a good rectangle. This would be bad. So here we're fine. But if I keep drawing these rectangles, you see that when I hit that x squared function, I now have a difference here. From here, it's just 1 take away 0, 1 take away 0, 1 take away 0. But when I hit this part, now it's 1 take away the function x squared plus 2. Not good. This means I need to do two integrals. This would be bad. This is a bad situation. So what method do we use? We use dis. So when we rotate this, as I move through the entire function, you can see that my rectangles are always going to be the same. So that rectangle has the same functions that that rectangle would have. It's going to always be the x squared plus 2 take away 0, x squared plus 2 take away 0. Always a height of x squared plus 2. So now we know which one to use. We'll use this one. We just have to make our formula. So area here is pi r squared, because that's what we're dealing with here is dis. So all we have to do is pi r squared. So what is our radius? Our radius is y equals. So in this case, our y is equal to x squared plus 2, right there. X squared plus 2. The bottom function 0. These are dis, so we don't have to worry about anything else being subtracted. It's just x squared plus 2 gets plugged in. And there we have it. So now we just need our integral. And remember, for dx, it's always the x values. So from 0 to 1. Put the pi outside. Plug it in our calculator, and we get an answer, which is 83 over 15 pi. Now this doesn't mean we can't use shells here. And if you were going to use shells, you could see you would still get the same answer. You just have to use two integrals. We'd have to go from 0 to 2 and find the shells here. So that would be a radius of y with a height of 1 plus, and then we'd have to solve this one for the x coordinate in terms of y, which gets complicated. We end up with that. It'd be 1 take away the square root of y minus 2 with a radius of y. But no matter what, you get the same answer. You can just see, look at that and look at that. So you always want to pick the correct rectangle. It'll tell you which method to use. So let's try another one. Now we're going to do it, but we're going to rotate this one about the y-axis. So if we're going to do the y-axis, then again, we'd have to pick for this one is perpendicular, and this one is parallel for shells. So if we do perpendicular with it, you can see that this one now is the bad one, and this one is the good one. So what method would you use? Shells. So if we're rotating this about the x-axis, then you want to pick dis. And if we end up having to rotate it about the y-axis, you pick shells. This is why we have two methods, so that we can use these nice. So now we can label it. This is dx, and this is y equals. And you can see that our height here is our function. So let's go back up and look and see what that was. That's x squared plus 2. So we now know our height is x squared plus 2. We know the width here is going to be x, so the radius is x. And if we rotate it, there's our shell right there. And we can continue it if we want to get that same exact solid, which goes here like this and there. And so you can kind of see the solid. But we end up with an area of 2 pi rh because we are using shells. So 2 pi x squared plus 2. So this is 2 pi and then x cubed plus 2x. And then again, we do the same thing. That's 0 to 1, 0 to 1, 2 pi, and then x cubed plus 2x dx. Now, these are not the same rotations. So up here, right, it gives us that shape here and that shape up there. So if we copy that graph, that's the shape that we're getting. So you can see they're not the same. This one is like a pedestal, and this one has like a pedestal with a bowl on the top. But we plug this in our calculator, and it will give us our volume, which gives us 5/2 pi. And so again, you could still use these. They're just bad. I didn't say they're impossible, but you look at it, you have to do, in this one, we'd have to use dis and washers. So you'd have to do one for dis from 0 to 2 for your y, and then one for washers from 2 to 3 for your y. This is just so much cleaner. So always pick the correct rectangle. And if you don't remember which one to use, go back and watch the video on good rectangles and bad rectangles.